Alright YouTube, hello, thank you for watching. You know, it's kind of times like this that the Jerry Reed song comes to mind. She got the gold mine and I got the shaft, man. Got the shaft. Got something that looks pretty damn beautiful here, but boy, this amp board does not run. It was kind of a no sleep till Brooklyn experience for me here. I think I've been up for about 6 days straight on this SOB. So far I'm losing the battle here. But anyway, show you a couple things that I did here. By the way, the disclaimer is everything that I designed works perfectly just as it should. However, every piece of shit that was piled in this box that's original to this box before I gutted it has been subject to possibly not working. So, you know, if I mess this up, trust me, I'd be the one to tell you. But this ain't my doing. Had to drag out the TRC 449. Holy cow, that's a 45-minute video on that one. Alright, take a gander at that beauty. That there is the culmination of 10 pounds of shit in a 5-pound bag. And boy, if you didn't see what it looked like before and you think this is a damn mess, you ain't seen nothing yet. Go back and check out the other video of what it was before I stayed up for 5 straight days. So I told you I would get everything in there, and I did. So there's the filter cap board. This is the relay that's going to drive the light display. The power supply part, I put all on the back, nice and neat on standoffs. Used the same existing LM723 that was in this monstrosity before I put the wire cutters into it and gutted it. Because I always like to take a couple pieces of the junk pile and incorporate them into something better. But you got to kind of watch that, because if you take the wrong part of the junk pile, you're gonna end up with problems. Now this here, take a gander at this shit, man. This here is working out well. It does exactly what it was supposed to do. The design of it is flawless. However, the amp board, like I said, is it's a lost cause, kind of, sorta. This is the bias board, and it's also the modulation monitor. We'll just call it that. Which is kind of a pointless thing, but the only reason I did that is because this guy put a mod LED in it, and there was really nothing I could do with it, so I just had to build a circuit to drive it. So the bias and the mod driver board is on the side there. Now, like I said, when you get a real piece of shit like this, sometimes it's better to throw everything away, and I'll tell you why I say that. It's because of this. I decided I was going to keep the rectifier out of the original mess. Well, long story short, when I went to test this, I spent 3 days getting intermittent blown fuses on the AC line for no apparent reason. And I said, you know, that just doesn't make sense, because this power supply is current limited. It can't produce an output current on the output of the power supply that would be great enough to blow the AC line fuse. So anyway, long story short, it looks like the original rectifier was failing intermittently. I'm blowing a damn fuse, so I had to scrap another project to get that in. Now this is where things get a little bit hokey. I am not an expert. This is probably a 1970s amp. Uses the TRW PT 9803s or something like that. 3Made would know what these are. I think he got mad at me and unsubscribed to me. Yeah, sorry, number 3, man. I do love you, though. But anyway, trying to find a schematic with these PT 9803s on from an amp board in the 70s has been kind of a clincher. Now, when I see shit like this, and I'll just tell you my thinking, I could be wrong, but here's where I'm heading with this. There is a very, very odd value cap, neglecting the fact that it's not connected. It is a 342 puff cap. It was soldered right here as it came in the door to me. Now here's my thinking on this. This is an oddball cap. Therefore, chances are it could have been part of the original amp board here, if you kind of follow me. However, it doesn't exactly make sense to me that this 342 is supposed to go across there, because this here was all hacked up with solder. So I think what they did is they just took this from somewhere on this board, possibly, or hell, you never know, it could be another board, and kludged it across here. But here's what I'm thinking. I'm thinking that this guy here might have had some sisters and brothers, because there are no base to emitter caps and there are no collector to ground caps. So my point is this: it would not surprise me if this 342, which is obviously a very, very old cap, probably old enough to date this board here, wasn't setting on this transistor at some point, somewhere, if you can kind of follow what I'm saying. Now, kind of the clincher is this: you got to be a good detective when you buy this bullshit. They like to take these caps that are sometimes in there and shift them around. Well, my point is this: there's a boatload of holes, almost too many holes, pulled through the board on these emitters right here, if you follow what I'm saying, plated through holes. Almost as if there could have been caps setting in those holes original, and somebody pulled the caps out. Normally you will have plated through holes at your emitters because they need them, but this board seems to have too many, and that's kind of a little leery to me as to what the hell they're for. That's why I'm thinking there was caps on there. But once again, that's kind of a big mystery of what they are, or what have you. This is an Arco 463 setting there. I pulled it, checked it, and it is what it's supposed to be. I'm sorry, an Arco 465. My camera does stupid shit when I put my hands in front of it. I don't know why that is. So that's an Arco 465. Kind of makes sense. Could possibly be legitimate with the value of a 465. I think they go up to about 280 puff. It almost seems to tune slightly towards maximum compression, so I'm not extremely suspicious of the collectors here. This is an Arco 463. Semi-suspicious of it, but not entirely. That maximum compression, this brings out at about 190, 193 puff. Makes sense to me. That's pretty much about what an Arco 463 should be. However, that seems like a lot of capacitance to tune the output. Now, this trimmer wants to be the whole way in. There could possibly be a very, very small tuning point, but I mean, it's so small and insignificant you can't tell, and it's almost at full compression on this trimmer. So I'm not super suspicious of those as to why this piece of shit doesn't work. So the question is, was there caps collector to ground? Was there caps base to emitter? My guess is there probably wasn't a tuning cap across here originally. But you know, that's my guess. Now, for the beauty of it all, gotta take a gander at this shit, I'll tell you that much. He got the gold mine and I got the shaft. Because I guarantee what he got doesn't work anything like this does. God have mercy on me for saying that, but you know it is true. He got something pretty flawless. I got a pain in the ass. I'll show you the definition of ugly here. Now I got the TRC 449 cut back to about 7 watts PEP, so I got the ALC turned way back on it. Hello, 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 hello. So it's drawing about 6 amps. Best I can tell from this amp meter. I think this amp meter is a little off because it was calibrated for a steel panel, and obviously it's not on a steel panel. Now the current limit on the power supply is actually what I do trust, because it was all made by calculator, and calculators don't lie. At 8 amps, this thing goes in to current limit. And you will see it is clearly going into current limit. Hello, hello. 10.3 volts coming out of the power supply. So that's why I say I think this amp meter is reading much lower than what it really is. Hello, one, hello, hello, check, check, hello. Hello, 1, 2, 3, 4, 5, hello. Even so, this amp should have some significant amount of power out of it, whether VCC's dropping to 10 volts or not. Hello, hello, hello. I don't know what is up with that honky ass waveform right there. Hello, check, check, 1, 2, hello, check, check. It's got all these jagged peaks on it, and kind of looks more like a triangle wave that's trying to form than a sine wave. Hello, check, check, hello, 1, 2, 3, 4, 5. Here's the old watt meter. 20 watt scale. Hello, 1, 2, 3, 4, 5. Hello, check, check, hello. About a whopping 18 watts coming out of that. Hello, check, check. 18 watts of jagged ass RF coming out of that amp. I mean, I don't even know how to wrap my head around that one. Now, strangely, well, not really strangely, if I flip this guy to AM, it just basically it takes the bias out on the transistors, so you get a shit pile more of a nightmare on the scope. Hello, check, check, hello, 1, 2, 3, 4, 5, hello. Hello, check, check, 1, 2, 3, 4, 5, hello. So my bias circuit works perfectly. The damn amp doesn't. Hello, check, check, 1, 2, 3, 4, 5, hello. What the hell? You know, I just don't know. But I will say this is this is the most inefficient jagged ass amplifier on the face of the planet. I'm pretty sure of that. Because let's just say that this is drawing 7. Well, we know it's going into current limit, so we know it's hitting 8 amps. 8 amps at whatever the voltage is dropping to. And we'll just say 11 volts. So that's 88 watts of input power, give or take, depending upon how much audio I'm putting into it. So basically 90 watts of input power to make 16, 17 watts. I've heard of low collector efficiencies, but kind of thinking this is a new one on this one. We'll be conservative. We'll say it's actually putting out 20. So 90 watts of input power. Yeah. About 22% efficiency. Came too far to turn back now. It would be helpful to know what this amp board is, what it came out of, because then there's always a possibility maybe I could find a schematic for it, or even find a picture of it would be even helpful. Wouldn't have to be actually a schematic, just having a picture of this amp board. But without knowing what brand it was, I mean, there's no way to do that. That way I could tell if there's some caps that are supposed to be on here that aren't. So yeah, I'm kind of really up shit creek without a paddle here on this. So I don't know what worst case scenario is here. You know, I wanted to save these TRW transistors at all cost. But if you don't know what the support components for them need to be, it almost stands to reason the only way to get this damn box running after these probably, hell, 50, 60, 70 hours in this box maybe, would be to gut the damn transformers out, pull the transistors out, drill and tap the heatsink, put some SD1446s in it, and go with a transistor where you know the design around it. That's the only thing that makes sense, but hell, I've done that already and it's not really fun to do. Plus this thing's kind of somewhat assembled. The obvious reason why I wanted to stick with the TRWs is because they're such low power. And that's what I wanted this for. I wanted this to drive a 4-pill. So I was only looking for 30 watts out of this box. And I figured, honestly, I was going to have problems dropping the output power down to get 30 watts out of it. I didn't know that it would be the other way around. So that's why I was partial to these TRWs here, because it would be easier to knock the circuit back to get, say, 30 watts out of it. That's my only expectation. But yeah, we can't even do that. And it's kind of funny because it pissed me off a while ago. So I took the clip lead and I clip leaded across the current sense resistor, and I thought, okay, you want to keep going into current limit? We're going to take you out of current limit, you son of a bitch. So I put a clip lead across it, keyed that thing up, yelled into it. Of course, the voltage didn't drop off because it wasn't so much going into current limit, but it blew the hell out of the fuse going into it. So yeah, that's counterproductive, because this amp should produce more power than this at a much lower current. So you know, it wouldn't matter if I took current limit out or not. There's something wrong with this damn board. So I'll just have to keep banging away on it. I don't know what else to do. It's just a can of worms that I opened here, and I probably shouldn't have, but you know, I guess I felt like I needed a challenge. It just kind of sucks because, man, I got so much time into this thing. Now, one other thing I almost forgot to mention. When I checked the beta on these two transistors, I got something that I kind of sort of didn't expect. I got a beta of 2. I would have probably expected to see like a beta of like 30 or 40 or something like that. What that means, I'm not quite sure. You know, do I think these transistors are the cause of this? Not really, but you know, hell, you never know. I've seen audio transistors test with absolutely no current gain the same way as these, and the transistors be good. It's just there's something funky about the curve, and without having a curve tracer, there's really no way to tell, because these little cheap beta checkers are really no way to test a damn transistor. I don't really care which one of them you got. They're all, in my opinion, worthless as tits on a boar hog. If you want to check a transistor, you really need a Tektronix curve tracer. But yeah, I just wanted to throw that in there. So I'm not sure what I'm going to do with this thing here at this point. Obviously just going to have to set it aside till I can maybe find some credible information on this particular board. But anyway, I just wanted to go ahead and put this on. I completely did not expect to do this here and to put so much time into it. I was kind of thinking I was just going to throw it into a closet. This thing is seriously taking away all my chemistry time, and I just can't have that. But anyway, so hey, I appreciate you checking this out. Thanks for watching. You take care and have a nice day.